And the broad talk I want to start with, that I think you can speak to and have spoken to in the past is sort of, the idea of use in biology and biological research. And to start by talking about that, I want to read two quotes. One from one of your books, your latest book, Life of Belief, and another from the New York Times, actually. So in the last section of the last paragraph, basically, of Life of Belief, you write, even if what we do has no social benefit, and even if we could state with confidence that our present activities will never confer that, science should be supported as a resource of people and facilities available for mobilization. All of us can enjoy, or ought to enjoy, science as a source of enlightenment and aesthetic pleasure, no less than what we find in music, art, or literature. And then you finish by saying that sentiment motivated you for writing this book. And so the second piece I wanted to read actually comes from last week in the New York Times. A columnist and a science writer writes about wildlife stuff mostly, wrote this article called Useless Creatures. I just want to read you a couple quotes from that because I think it's a sort of a shared sentiment. And it's interesting that that sentiment is up in the popular sort of sphere. The title of his piece was Useless Creatures. And in the introduction he writes, I'm bored of pretending usefulness is a thing that really matters. And he goes on to write about wildlife. He gives examples about what he writes about for wildlife biology. And then the end of it is wildlife is and should be useless in the same way art, music, poetry, and even sports are useless. They're useless in the sense that they do nothing more than raise our spirits, make us laugh or cry, frighten, disturb, and delight us. They connect us not just to what's weird, different, other, but to a world where we humans do not matter nearly as much as we like to think. And that should be enough. So it's a similar sentiment to what you state in the last of the book. And I know this probably comes up a lot in what you've done.
Well, in general, when one is asked about the science you do, you're asked either about why it is going to be useful, or what is the justification for spending the money, or something like that. And you're not asked in any very basic sense, why do you do it? Or if you ask why you do it, you are so conditioned by the external world that you give the answer that you are expected to give, which is, well, it will do this, or it might do that, or it might lead to this bit of technology or that, rather than the answer that deep down is what motivates you, that you're just darn curious what's going on, and you've got this question needling you in the back of your mind, and you somehow have to do something about it, and that you've been doing science for a few years, and that every question you answer leads to two more questions that you'd like to answer, and the tree of unanswered questions just keeps flourishing and arborizing, and you're stuck with it in a certain sense of almost an addiction. That doesn't sound right somehow, and so we don't talk about it that way. But it's like asking an artist to stop painting. You want to sell your paintings and make a living from it, but in an odd way, that's an afterthought. Where were all these painters that suffered severe poverty rather than doing something gainful or more gainful? Well, they got hooked on it. And in a sense, we're hooked on science that way, and at least we don't have to suffer extreme poverty, at least most of us. But it doesn't sound right to say, well, I'm simply hooked on it. I'm curious. My mind is restless.
Mm-hmm. Well, what do you think that translates to in terms of, value, cultural value of research? So, an artist, sort of the value of that is communicating to an audience, right? And interpreting something in a way that other people perceive. But
I think they're two completely separate ways of looking at it as far as, say, cultural or at least human value. One is, in fact, this sort of cultural value that I think science is the cultural, it is the cultural scene, the main scene of our era. Not painting, not art, not music and so forth, much as I like both of those. But the real triumph of human artistry in the 20th and 21st century, I think, is science. It's just a triumph of the human imagination, disciplined to actually get a view of the world around us, a very much more powerful view than the best of art. And that's a very powerful motivation for perhaps a society to support us. But that's only one. The other one goes back to something that maybe we don't like to think about all the time, and takes a little bit of explanation. But at the beginning of World War II, the U.S. had to mobilize an army from almost scratch. There was a bit of an officer corps and a small army, but they discovered they could make a pretty credible officer in a couple of months, and they could make a foot soldier in a matter of 6 weeks, and they weren't all that bad. But we also decided to build an atomic weapon. We did not train a single engineer or physicist. We depended entirely on what we already had. Now, I think it's highly likely that we'll be facing technological challenges of an extreme sort in forthcoming generations, and we'll recognize and solve those challenges as they come along based on what we already have in the way of a scientific establishment. When one comes along, it will probably be too late to start training that establishment from scratch. Training the teachers who will train the students, who will train the people who will go out and do whatever it is. The lag time will be too great. Mm-hmm. And so that's the other reason. We're a peacetime army, in effect. We're the fire truck that sits while it's sitting in the firehouse. The trouble is the fire truck in the firehouse doesn't take a lot of maintenance. A little bit of practice once in a while. We take a sort of continuous level of maintenance. On the other hand, we're a great deal cheaper than a peacetime army.
Right. Yeah. So it's almost like the biologist in that sense is sort of it's a cultural good. It's like an investment, basically.
We're an investment.
Yeah.
Yes. We're something, never mind the specifics of what we do at a given time, we're a resource. And unless we do things continuously and do things of the highest quality that we can be persuaded to do, and with our feet in the fire as far as peer review and so forth, then we won't be available if something comes along. The recognition and amelioration of the ozone hole is, I think, a good case in point, mm-hmm. where it was recognized by a couple of classical scientists, not technologists, mm-hmm. and the cure was a matter of looking into the scientific records of what we had available, and it was done again on the pre-existing resource. Mm-hmm. And that has actually been one of the great successes.
So how do you think that plays into topics that scientists study? Because usually, myself, I'm a behavioral biologist studying social insects and also a chemical ecologist. And the stuff that I do, admittedly, is pretty esoteric, like describing how ants behave and communicate. But how does that translate,
You can do a lot more than that, though. We found that out again in the war years. People didn't do just what they were trained to do. That's one of the nice things about the kind of, you're not trained entirely, you're educated. Mm-hmm. You do a thesis, it's work that's original. You're not just following somebody's cookbook. Mm-hmm. And this gives you a kind of intellectual and scientific versatility which you may not even recognize that you have. Mm-hmm. So you can be bent into other pursuits rather better than I think you recognize.
Okay.
Look, I do things I was never in any formal sense trained to do. Mm-hmm. I never took a course in biomechanics, and that's what I do. I wrote a whole book on biological fluid mechanics, and I never took a course in fluid mechanics. I audited part of one, but couldn't do the math. Or put another way, every good scientist that I know we have a term for it. We call it an autodidact. We are all autodidacts, meaning we are capable of self-education. Mm-hmm. That's part of the game. That's the nature of this peculiar degree that we call PhD. It basically certifies that you are an autodidact.
Yeah, that's an interesting way to look at it. So the reason why I bring this up is I actually first encountered you in your writings when I was a graduate student, and I got basically conscripted by a design school to come in and talk about how biology might be applicable to human design. And so I started teaching in that. I supported basically my graduate career off of working with those designers. And of course came across your books and your writing because you have spoken to that a lot. And this field is the current version of that is called biomimicry, right? That's
Yes.
the entire field, but that's sort of a new term and a new bent on it a little bit. I wonder if you can speak to that and sort of the idea that idea of sort of technology transfer and what the pitfalls are and what your experience with that is. And
Well, I think biomimicry encompasses a whole spectrum of things. I think it's a little bit oversold. Direct transfer from what nature does to what humans just might do in technology has occasionally worked in the past and will occasionally, I think, work in the future, probably more in the future than in the past because we're getting a little better handle on what nature does. But as I say, it encompasses a fairly wide spectrum, ranging from rather hard-nosed technological studies in detail to the sort of wide-eyed, go out in the field and here's this forest, look at all the things that we can possibly copy, and very little comes out of that. You don't even know what nature's doing and why she's doing it and what is multifunctional and what is not, and you don't know what the games are. So and its motivations are variable from, again, rather hard-nosed attempts to do rather specific things that nature seems to do rather better than we do, to a kind of engineer bashing that sort of says, well, gee, if we did it nature's way, we wouldn't be in all the trouble we're in now. The trouble is we've deviated from the normal, the natural, the good, the, beneficent, whatever else, has a kind of a theological overtone to some of it. So it's a wide range of things. I don't want to, I'm a kind of agnostic in the whole business, although I did one very specifically biomimetic project once, and it seemed to work out reasonably well, although nobody has...
The nose home?
Yeah. Nobody has commercialized that particular one. But it sort of established my bona fides in biomimetics after being sort of the bad boy of the field, since I was the one who pointed out that the historical record of biomimetics is rather poorer than most people think. Yeah, it's become a little more fashionable than I'm happy about. Riding for a fall is one of the expressions. The two technologies, that of nature and that of humans, are very, very different in how they go about things, and it makes it rather tricky to transfer from one to the other. On the other hand, when nature does something, it does absolutely tell you it is possible.
Yeah.
And sometimes just that notion of possibility is a very, very strong thing. Will you undertake something when you're not sure it's possible? Well, you're much less likely to.
Yeah. The one, when I was immersed in this in graduate school, the one wall that I just kept on running against and sort of trying different ways to express and to get across to students outside of biology is sort of the different ways that that problems are solved. Like there's, nature's not goal oriented, right?
Yes,
but human design is goal oriented, yes. And that just getting across that, it's like such a,
the word design itself has two very, very different meanings in nature and in human technology. I think, though, there's another way to look at it, and that is, if you look at how we do something and how nature does something, and they're virtually always the same. Bamboo shoots are hollow, bicycle frames are hollow. You see the underlying logic behind the system in an engineering sense. And if it's always the same, then you think, well, this is a highly constrained system. Maybe we better stick with it. But if you see two different solutions Well, you can say, well, maybe we ought to try nature's solution, but there's also something else you can think about, and that is, gee, if we do it one way and nature does it a different way, well, it's an unconstrained system. Maybe there's a third way and a fourth way and so forth. So the comparison of the two technologies, I think, is as important as biomimetics directly. The comparison gives you a sense of the degree of constraint on the design of what you're doing or what you're interested in doing. Mm-hmm. And that's a powerful thing. Mm-hmm. But it's a much more abstract thing.
Yeah. So I noticed that you've done some consulting for actual companies, for actual, like Procter and Gamble.
A little bit.
Yeah.
Yes, but it hasn't. It's at a very low level of involvement.
Well, what was that? What did you do?
Oh, one of the people in their sort of think tank, far out division for possible future products had some odd ideas he wanted to bounce off somebody in the life sciences. It was not much more specific than that.
Okay.
And in fact, it was remarkably unspecific, and we had rather a lot of fun. And I had no idea there was anybody in a company like Procter and Gamble thinking so abstractly. Maybe the company didn't know what he was thinking about. And what they were paying me for.
Yeah, so you were basically just an audience?
Well, no, I was suggesting things he might read and criticizing things that he'd written, and I never did see any connection with anything they might have done. I did spend one day actually out there on a rather more specific project, where I'm sure I was of virtually no help whatsoever, but most of it was done by email and so on, on a very, very abstract level.
Yeah. Yeah.
Now, I must say, in defense of the company, maintaining somebody that is as free-thinking as that, in the end, it was not a bad idea. Mm-hmm. And some of the large companies actually do this, keeping people around who, they only cost a salary. And sometimes it's worth it. I knew someone I think he died recently, who worked for Boeing, who generated the most wonderfully creative things. And whether a product ever came out of it or not, I'm not sure. But he did some lovely, interesting thinking about paleoaerodynamics of birds and things like that, and designed futuristic aircraft and so on. And well, maybe who knows whether something came out of it, but he certainly did not represent a large expense to the Boeing company.
Mm-hmm, mm-hmm. So throughout your career, when you're looking for research support through grants or through whatever, have you used application in like your grant applications?
Oh, everybody does.
Yeah.
You can't apply for money these days for anybody without making up some sort of gee whiz story about how it's going to make a better widget. The extent to which you actually believe that, nobody wants it. Sometimes you don't even want to ask yourself, much less ask somebody else. At least, even if you do believe it, it's probably not your principal motivation.
Right.
At least among the people that I know, or the people that whose science I value or think is first rate. Uh-huh. Mostly my attitude toward grant support has been to avoid it wherever possible, for several reasons. First, it takes an enormous investment of time to get it. And secondly, you're making promises which direct what you're doing and constrain your future activities. And if you can possibly do your research on pre-existing equipment and do it without specific external support, meaning promises, then you're far less constrained in what you do when you get up in the morning, and you're not otherwise limited in your day's activities by appointments and courses and things like that. You can say you can follow your nose a little bit better. Mm-hmm. So I've avoided. I've had support but not continuous, and it's usually been in the latter phases of a project where you're cleaning up the details or something like that, mm-hmm. While doing the pilot experiments for something else that you haven't told any granting agency about, because you haven't any idea whether it's going to work out or not, or whether you better just quietly bury it.
Yeah. Yeah. I wonder. So what do you have any specific examples of just looking over your career and sort of what you've done? I mean, out of your research has come, I think you have 11 books, right?
Well, it depends on how you count different editions, but it's on the order of 10 books.
Yeah. Okay. So do you view that as the main sort of a public output of your research? I
I
wonder.
do. It has an odd history. I assumed I'd be or do science the way most scientists do science and produce papers and so forth, and I've done a certain amount of that. Less collaboratively than most scientists, but that's just a matter of personal style. But I didn't expect I would write books. I simply didn't think about it. The fact that I found writing easier than most people was something that was just there in the back of my mind that, again, I never thought much about, that I always opted for the term paper, not the the sit-down exam. Term papers just never bent me out of shape. But again, it was not anything that was front and center in my mental processes. I was about 40 and I was teaching a course doing some biological fluid mechanics, and there was no book, and I took a deep breath and had a sabbatical and couldn't find a co-author, and so I started writing, and after about the first 10,000 words, I really got excited. I mean, I could write a book. And my wife still laughs about that time because I got so excited I could hardly sleep. And it all happened, and the world liked it. And, my life was thereby changed. And a few years later, when I was, I guess about 6 or 7 years later, I tried another book. And the world liked that one too. That was a Life's Devices book. And a realization came on me, sort of an epiphany, that the books made more difference to the advance of my own interest and field than anything that I could do in the lab with my own hands. That was a terrible realization because I like to do science with my own hands. But if I took the coldest possible view of what would advance my field, it was to stay out of the lab and write. It's like the part in HMS Pinafore, Gilbert and Sullivan's Pinafore, where the fellow says, stick close to your desk and never go to sea, and you'll be Lord of the Royal Navy. Or you could modernize it and say you'll make a big splash in marine biology. Well, I continued to do science with my own hands, but not with the intensity that I ever thought I would, and continued to do the books. Yeah. And I think that epiphany was not I was not misleading myself. And so I've continued to write. And also it has had the fringe benefit of giving me a very, very nice transition into retirement. Because if you hardly notice that you're now retired and writing books instead of not being retired and writing books. Yeah. At the moment, I'm doing some writing and I'm teaching a course. But of course I don't go to faculty meetings and things like that.
Do you think if you started fresh, if you were 30 years old right now and starting a fresh tenure track position, do you think that sort of output, that sort of scientific output would be I think where do you think that would enter into your career after having this realization of sort of the impact of that stuff?
Well, it's hard to know. I was, in some ways, the beneficiary of a very odd demographic accident. And I didn't realize this. None of us really realized it, I guess, at the time, but I got a PhD in 1966. Now, the people getting PhDs in 1966 were mostly born in the late 1930s. There were very few people born in the late 1930s. It was the baby bust, you might say. At the same time, the peak number of births per year in the U.S. was in 1957, that late. Meaning by the mid-60s, the universities all across the country knew that they were facing a big wave of potential students that were going to hit in the 70s and thereafter. So they were all expanding. This is when the State University of New York and the State of California, every state university was sprouting campuses. Well, they had to staff them with faculty. And so they were going at us. I mean, many of us didn't do postdocs. I got a few weeks after I did my thesis exam, I get a phone call, come for an interview. I mean, it was the most forgiving time, a seller's market. And of course, when you came up for tenure, which I did in the early 70s, well, departments didn't want to go back into that miserable labor market and try to recruit somebody else. So it was an extremely forgiving time as far as getting position at a good university and getting tenure. So you had a lot of wiggle space. We did a little more teaching than possibly people did now. You could invest more heavily in teaching, which I did to an extent that would be probably professionally suicidal now. But in the process, I wrote a lot of teaching material, learned a bit about teaching, learned about how to write unambiguous prose for large laboratories and large courses. And and also because I was teaching very general material, my whole set of intellectual horizons broadened out after the narrowing that graduate school provides. So it was a very forgiving time professionally and intellectually. Now, we turn the heat on young faculty members in a different way. I did a PhD thesis on the aerodynamics of insect flight, probably ill-advisedly in terms of my basic fluid mechanical know-how, but I think I probably would have had to continue to pick around the edges of that field and not been in effect given enough wiggle space to change orientations. I finished the fruit flies. I hated those little guys. So I switched to low-speed thermal cooling in leaves. Mm-hmm. Talk about a big switch.
Yeah.
Built new apparatus. And there was a hiatus in my output, but it didn't matter. I ran that for a few years and just got tired of it. After about 4 years, there was still plenty one could do, but I sort of got tired of it, and I had a better idea. So I switched to induced ventilation in things like prairie dog burrows. Mm-hmm. Another big switch.
Yeah.
And
then some marine organisms.
And some marine organisms as well. Limpets and Keolimpets and others.
Sponges.
I mean, and this was all pre-tenure.
Yeah.
You couldn't do that now.
Yeah.
So I'm teaching freshman biology and completely reorganizing the laboratories and building new equipment for that and switching my professional orientation twice. Well, my output in papers was not exactly high, but didn't matter. So what would happen now?
Different.
I'm not suicidal. I wouldn't do it the same way. I'm not. I mean, my self-destructiveness is got its limits.
Yeah.
Besides, I had a wife and kid and so forth. I mean, and a mortgage.
Yeah.
No, I'm not going to be. I'm not a radical individual in terms of personal behavior.
Doesn't it seem like public perception of scientists and value of science is more important now? It's more of a major task that scientists face. Like, cause there's, senators that will pick out whatever stimulus funding to study whatever thing.
Oh, we had Senator Proxmire and his Golden Fleece Award.
Yeah.
And so forth. I mean, no, I think this goes on back. There's been a sort of, not just anti-scientific, but an anti-intellectual, current in, American, public life that goes way, way back. We're talking Scopes trial and going back before that. So I'm not sure things are any different now. Okay. Trying to take my best historical view of things. I mean, half the criticism of Darwin, there was some reasonable criticism, but an awful lot of it was basically anti-intellectual, anti-scientific, anti-rational. No, the persistence of the irrational is there. Maybe it's worse. I don't know whether it's worse now. It's hard to say.
Yeah.
I lived through the McCarthy era. Remember that all too well. I won't say things are better, but I won't assert that they're enormously worse
or different.
Yeah.
Yeah. Okay. So let's go back to 1940, 1950. What was the first impression that you had of doing something like biology was possible? Did you have any impression of that before going up to university?
Well, I was interested in biology, but not because I loved animals or plants or whatever. I'd run into an extraordinarily interesting teacher when I was in high school. In fact, he eventually got a PhD about the same time I did.
Oh, wow.
After being self-educated in biology, he was originally intending to be a Spanish teacher, and I was the kid he talked to while he was teaching himself biology. So it was a very enriching experience at a small school I went to, and that probably got me interested more in biology than in, say, physics or chemistry. But it was biology as an intellectual enterprise, not because of touchy-feely stuff.
Really?
Although I did have access to a microscope as a kid because my father was a pharmacist of the old-fashioned sort, so I was comfortable at least with that.
What were the intellectual things about biology that intrigued you? Like, what were the questions?
Well, he was in particular interested in ecology, and that was the field he stayed with. And so I got interested in it and read a good chunk of this big book by Alley, Emerson, Park, and Schmidt. It was the dominant, the sort of statement of where ecology was as of the early 1950s. And it seemed enormously interesting. Now, I didn't ultimately stay with ecology. I went to college, and the particular place I went didn't happen even to have an ecology course. Well, it did by the time I graduated. But I never could think of a particular operational question I wanted to ask of ecology. It was, I won't say seriously frustrating, but I took a physiology course, and the physiology course really talked to me. It was somehow, I don't know about being less abstract, but you were dealing with single factors. You weren't dealing with such a level, with quite the level of complexity of an external world, and I could get my hands around it, and I stayed with that because somehow that was the area in which I could ask specific questions and see specific experiments that would give you reasonably crisp answers to those specific questions without some enormous data sets and statistical analyses, which ultimately have always left me a little bit unsatisfied. So I still am interested in ecology, but I don't do it as such for probably the reasons that I more or less walked away from it when I was 20.
Yeah.
It's a matter of you have to not only be interested in the field, but have some sort of handle on how you can do something in a field. And I never had that.
Yeah, because you wrote in one of your publications about teaching biology. I think you wrote, let me read the quote, that you were a biologist, in spite of, not because of, your first college course.
Oh yes, I very much disliked my first college course. Part of that was that it was terribly old-fashioned. Names and places and more names and places. And the first semester was plants, and so you did life cycles of plants. And the second semester was animals, and so you did life cycles of parasites. That's mostly what I remember. But part of the frustration, you see, was that I had this very enriched background in biology, talking to this fellow who was learning the stuff and bouncing the ideas, the really interesting central ideas off this odd high school kid who just happened to be interested. And then I end up in this freshman course, which was, just as I was not so much uninspired as contentless in any sense of ideas that I hadn't heard before, and covered very, very little that I cared anything about.
I wonder how that affected when you taught introductory biology.
Well, that was the first thing I decided. I wasn't going to teach it anything like what I had. I didn't want, that I was going to teach a course that was about ideas. I think there were a lot of students who were frustrated by this. They wanted the names and places. They didn't want a course that, I never used a multiple choice question in all the years I taught beginning biology because I was afraid it would bias me toward names and places. I didn't trust myself.
Okay.
You see, to make up the kind of questions. So I was trying to teach a course that asked, that was not like what I had. In a more positive sense, I took the tack in teaching beginning biology. This was the last course that any student would have, major or non-major, that would talk about biology, would look at biology as a whole. Every other course would take a part of the subject. And if there was a subject called biology, it wasn't just some, federation of other fields. Then there must be something to be said about it as a whole, the same way as physics has a the essential core that is physics, Newtonian physics or whatever, and that biology also. I was trying to discover what's the center. Of course, we have evolution and so forth, which is our special central principle, and we have some other things having to do with the complexity and persistence, how organisms manage to inherit that complexity and improve upon it and so forth, and a few other things that Plus, I mean, there's blood and guts going on and feedback processes and control and things like that will come in again and again and again. None of which, of course, had been covered when I took beginning biology.
Right.
But I built around those ideas that this was the last course you'd ever take in biology.
Mm-hmm.
And I think that was I don't know whether I ever actually said this, but that was the way I was thinking about it.
Okay. Huh. When were you given the opportunity? Was this pre-tenure that you started teaching this, like as a new assistant professor?
My hiring was in connection with a beginning biology course.
Oh, okay.
That was how the opening was made. There were two departments, and they had agreed to get together to give a beginning course, and they had at least one additional faculty slot had been opened in connection with this. Mm-hmm. Now, I was terrible at it the first couple of years, but
you had the negative model fresh in your mind.
Oh yes,
yeah.
Oh, yes.
Yeah.
After, I don't like to meet people. Took the course in the first 2 years, mm-hmm. but after 3 or 4 years, it started working, and I still run into people who've had it and liked it. Mm-hmm. It worked for them as an introduction to sometimes a full year, sometimes a semester, depending on what kind of curricular revisions we were doing. But I think I taught beginning biology in one form or another, I think for 18 years.
Oh, wow.
My normal the normal course I would have taught in the mainstream course would have been physiology.
Yeah.
Coincidentally, I never did teach it.
Huh.
Well, I got dug into beginning course, and there were a couple of opportunities to switch, and I had too much investment.
Right. So going back to your undergraduate career at Tufts, you got involved in research there. It's through Ken Roeder, is that right?
Ken Roeder, yes.
Uh-huh.
It was a wonderful bit of luck.
Okay, how did that happen?
Well, the story it's a rather funny story. I took this freshman course, which I thoroughly disliked. And I would have switched out of biology if I could have thought of anything else I wanted to do with any kind of degree of passion. But I didn't have anything else that really, really, got me fired up. So in those days, courses were taken in a fairly rigid sequence, not because it was written down, but because this is just the way it was. And sophomore year, you usually took a course in vertebrate anatomy, which was taught by another guy who I knew would be equally dull. And I couldn't face that. But somebody said something about a physiology course, so I figured, what the hell? So I took this physiology course that was normally taken by juniors. They were all juniors, except me. I'm a sophomore taking it. And I've taken this course with, so to speak, the big kids. And after the first exam, I really enjoyed it. After the first exam, I go around, knock on the door of the guy giving the course, who's a rather elderly British gentleman, Kenneth Roeder. Mm-hmm. And I say, well, I'm in your physiology course. He says, yes. I says, I took the exam, and he says, what's your problem? And now that I've been a faculty member, I understand. I mean, I'm just another, undergrad pre-med bitching for about, trying to get out a few more points for the grade.
Right.
I said, well, yeah, I don't know if it's a problem exactly, but I'm casting about in biology for an area that I want to set, I really want to work in. And, I really like this physiology. But I thought I'd wait for the first exam because it seemed quite easy, and maybe there was something I was missing. But I got the best grade in the class, so I guess maybe I'm not.
So you knocked on his door and said your test was really easy. I thought it was going to be harder.
Well, or something. I don't remember the exact words. But anyway, he calls me into his office and sits down, and we have a good long conversation. And he gets me into a course for the second half of my sophomore year, which is normally taken by seniors. A little course in general physiology. And I said, I can't do that. He says, don't worry about it. And that turned out to be another very interesting course taught by a guy who was an awful teacher in any formal sense, and very, very important in my life in a sort of intellectual sense. I mean, he was such a poorly cast as a teacher that in this group of about 10 students, we'd all sit there sort of pulling for him, saying, you can do it. You can get through this lecture. He was so ill at ease in front of a class. But You pulled through it, you pulled with him, and you learned the stuff, and, so on. Anyway, I stayed with the physiology. The way I ask questions is still a way that was in many ways formed up in Kenneth Roeder's undergraduate class. Now, it turned out that he was the only person that I think then on the Tufts campus who was a member of the National Academy of Sciences. I didn't know that.
Mm-hmm.
And he also recognized that I had to be socialized into being a scientist. So he found me a job in his lab, raising the blowflies to feed the colony of praying mantises that they had.
Oh,
so
wow.
I raised blowflies on decaying dog food, which had an awful smell, but, you get used to anything. And it was a nice, friendly lab, and I became part of the show.
Yeah.
And then by my senior year, I was actually starting to do a research project. I'd taken a seminar and so forth. And as one of the people in the lab said, poor old Vogel, he's going to go to graduate school. He's going to be like a first-year student again after the way we've been treating him. Because, you see, there weren't any graduate students there.
Oh, really? In his lab?
You see,
in Tufts?
So, at that time.
Wow.
There were no graduate students in that lab.
Uh-huh.
Almost none in biology. They did have a couple of master's students. So I got a lot of attention.
Uh-huh.
And had pretty much the free run of the place, and was, if there was a party, I went to the party, things like that. So I was just drawn in.
Right. Did you publish before you left undergraduate, or was it like concurrent with your first?
Well, my first publication was also rather funny. It was actually my first year in graduate school, but it was work that I did just as I was finishing undergrad. I actually had an intermediate semester where I got out of undergrad a semester early by recounting the credits so I could continue with a research project.
Uh-huh.
And the first publication actually came out. It was work I did at Tufts.
Mm-hmm.
And I had a little thing that worked out on me. I did something funny. You see, I didn't really have a lot of bias in terms of what field I was in. The lab did neurobiology, and did something. The question came up about something having to do with wing beat frequency in insects, very small insects. And the question had been raised, what's the neural basis of it? And I made an assumption that no neurobiologist would make, which was that nerves had nothing to do with it. It was purely fluid mechanical. Mm-hmm. I went out and bought a book on fluid mechanics. Mm-hmm. And by the luck of the draw, I got the right book. Mm-hmm. I bought it because it was cheap. It was a Dover paperback.
Okay.
and the problem dropped, the answer dropped in my lap. And I ended up, by the time it got published, I was in grad school. But I wrote up this short paper, and then I went looking for a journal that would publish short papers that didn't categorize very well by field. Well, I heard there was this journal called Nature.
Oh, yeah.
So
sure.
I sent it off to Nature. I said, well, they'll reject it, but what the heck. Anyway, they published it.
Wow.
So there I got it. A sole-authored paper in Nature as a 22-year-old kid.
Yeah.
But, the whole thing, why it happened and how it happened, it's a lot of this is luck.
Yeah.
And the extent to which we accredit planning it's self-serving. Mm-hmm. You keep, you follow your nose, you keep your powder dry, you take advantage of opportunities. That's basically the best you can do.
Yeah. So how did you end up with Carol Williams at Harvard?
Oh, well, that's another, again, a little bit of luck and so forth.
Because he was like a department head at Harvard during the time, wasn't he?
And that for his sins. I mean, they took turns doing it. At that time, it was the worst possible job. That department was coming apart at the seams. Uh-huh. But he was a loyalist, so he was willing to serve his term as department head. It was more that kind of thing.
Yeah.
But what happened was this. I was looking for a graduate school, and I went round to talk to Ken Roeder about it. I still remember that conversation because there are a lot of places you can go do graduate work, and I already knew what I wanted to do. I wanted to continue the work on fruit fly aerodynamics because I was already dug into it, and it was working for me. I'd had something that dropped into my lap, and I was going to, keep with it. So I needed somebody who would let me keep doing that kind of thing. I remember asking Roeder, if you had to go to graduate school, where would you go? If you had to do it again? And he just looked at me and said, I didn't do it the first place. It turned out his PhD was honorary.
Oh, wow.
I didn't realize that either.
Wow. True independent.
Well, he'd come through the Depression and so forth, and ended up at Tufts because he could be a grad student at Harvard. But he went over to Harvard and didn't like the classical entomologists. And eventually he became so well known that Tufts gave him an honorary degree. Wow. So anyway, but there was a fellow at Harvard named Carol Williams who worked on fruit fly aerodynamics for his own thesis back around 1940.
Oh.
And then gave it up as a bad job, decided there were other things he wanted to do, and became rather well known for his work on insect hormones.
Right.
But, was willing to take on a graduate student who was going to continue the work on insect aerodynamics, with the understanding that he wasn't going to be much help. But there was this guy in Denmark, and if you named Weiss Vogel, and if you got into problems, you could write Weiss Vogel a letter, and he, so on. So Ken Roeder made a phone call, and I went over to Harvard, which is only 2 miles away, and had a little chat with Carol Williams, and we got along reasonably well, and got fixed up that I'd go over there. Pretty much, I'd go over there as a graduate student. It helped because I had good grades and good board scores, so that wasn't really that much of an issue. Mm-hmm. So it was sort of fixed up. Mm-hmm. Although, as far as personalities, I really liked Roeder much better than Carol Williams. Mm-hmm. Roeder was he was more urbane. In some ways, Williams was brash and so forth. But we got on fine, and he always was a very supportive graduate advisor and so on, in a somewhat hands-off sense. I mean, that's why my publications don't have him on, because he said, well, I haven't, had any hand in this.
Yeah.
But he was very, very supportive.
Uh-huh. And you just mentioned Turkel Weiss Vogel, right?
Yeah.
So you must have had a correspondence because he wasn't in the U.S.
No, he was over in Denmark, and but we'd met a couple of times when he'd be in the U.S. or something, and I actually visited once over there, and I was going to do a postdoc with Weiss Vogel. Except
was this in Copenhagen?
Yes, in Copenhagen.
Uh-huh.
And the year I was going to do it, he was in transit from Copenhagen to Cambridge, where he became department head. Mm-hmm. That was actually the year I interviewed here, and came down here the year after. So the postdoc year sort of fell through because Weiss Vogel wasn't available that particular year, 65, 66. Mm-hmm. So I never did.
Yeah, it's an interesting small world that correspondence you brought up in graduate school, and because he worked with like a major sort of founding father of physiology.
He was Krog's last student.
Right.
Well, the other connection is that when I was was recruited at Duke, the phone call that recruited me was from Knut Schmidt-Nielsen, whose statue was outside.
I saw it.
We had this little ceremony to recognize a plaque next to that statue. And Schmidt-Nielsen had been an earlier student of Krog's and was good friend with Weiss Vogel. So I have this odd tie to this sort of Copenhagen school of physiology.
Yeah.
Which everybody talks about the Copenhagen School of Physics, and they're talking about Niels Bohr. Mm-hmm. Well, there's a Copenhagen School of Physiology, and it traces to Bohr. But Christian Bohr, Niels Bohr's father.
Oh, wow.
And, it's worth a little mention. About the turn of the 20th century, Christian Bohr organized the Department of Zoophysiology at the University of Copenhagen. And what was radical about this was he insisted that the Department of Zoophysiology be organized within the Faculty of Science and not the Faculty of Medicine. You see, all the famous physiologists, Claude Bernard, Harvey, they'd all been physicians or associated with medical schools or thought in terms of humans only. Mm-hmm. Animal physiology didn't really exist as a separate subject. And in a way, it began with Christian Bohr, whose student Krog, August Krog, won a Nobel Prize, and whose students then Weiss Vogel and Schmidt-Nielsen were. Mm-hmm. So we can recognize a Copenhagan School of Physiology.
Yeah, it's almost like
comparative physiology in the present sense.
Yeah, it's interesting. I mean, that's sort of a foundational thing of current comparative physiology. Just like in that same time period, in Germany, behavioral ecology was sort of birthed.
Yes,
with all that crew.
Yeah, behavioral ecology was created in Germany about that time.
Yeah.
I've forgotten the names of the founders, because I once knew. But
yeah, well, Lorenz and
Lorenz
the whole Nobel crew.
Yeah.
Yeah.
So physiology, well, plant physiology, you see, existed in botany departments, but animal physiology existed in medical schools.
Yeah, yeah. So you were recruited here by Schmidt-Nielsen?
Oh, yes.
Yeah, I love that statue. That I just read the plaque, and it says something like, I'm going to misquote it. It's fresh in my mind. It was something like, tell me about yourself, Camel, so I
should know myself.
Yeah, it's such a great summation of like why to do comparative stuff.
Yeah. Well, it's one reason to do it. It's to take the extreme case and where you're using all of the animals that you have available, or plants too, to really get a picture of what's going on in a fundamental sense. Mm-hmm. There are other reasons for doing comparative work, which I think were less well recognized. I've pointed out that one of the nice things is unique to organism-level functional work. You can look for convergence. And convergence is nature's way of telling you what matters, the finger pointing to functional significance. Mm-hmm. But even Krog's and Bohr's comparative physiology didn't think much about evolutionary biology, you see. And to start talking about convergence, you have to start thinking like an evolutionary biologist. But not exactly, because your classical evolutionary biologist and phylogeneticist is looking for shared derived characters. Mm-hmm. Your proper comparative physiologist is looking for shared non-derived characters. They're the ones that are important. Yeah. They're telling you what matters. Mm-hmm. And I started thinking once because I had to write something about this, that beyond my thesis work, which was on a specific species, everything I've done since has involved shared non-derived characters. If it's not widespread and convergent, somehow I never got interested in it. Mm-hmm. Took me 30 years to recognize that.
Well, it's evident in the list of organisms that you've studied. I mean, from plants to Drosophila to prairie dogs, sponges like silkworms, algae, scallops, squid, all of that.
What holds it together are a series of shared non-derived characters, or problems to which a good number of organisms had adapted with shared non-derived characters.
Mm-hmm. Okay, so we're getting close to an hour, but there's one person I wanted to bring up of a colleague of yours at Duke, which I think was instrumental in your career, Stephen Wainwright.
Yes.
Yeah. So he was studying marine organisms, right?
Well, he began studying marine organisms, and we ended up teaching together, and that's another one of these interesting stories. We taught beginning biology together. At least we were both involved in it. But we didn't really realize that we were in kindred fields, partly because his background is morphology. He's a morphologist at a very deep sense. He's a sculptor. He goes to art museums and has a kind of an emotional experience that I don't have. He's a blackboard artist. I can't draw anything. Mm-hmm. But I do a little better with numbers and graphs and things like that. Our scientific styles are different. He's very much more of a collaborator. I'm much more of a writer. So we've always gotten along famously, but we're very, very different people. Anyway, there was a graduate student here once named Mimi Cole, who's now a full professor at Berkeley and MacArthur Fellow, all this sort of thing, and because she's quite wonderful. She took the fluid mechanics that I was teaching and applied it to a problem. She was Steve's graduate student, which he had, I think, gotten her launched onto. And at the end of her thesis exam, we're sitting around talking, and it was obvious that we ought to be working together or teaching together. And so we created this course called Biomechanics, or Comparative Biomechanics, which took the fluids and the solids and put them together in a course, saying, look, organisms, everything's all movable anyway. You can't, well, that was Mimi's thesis. Mm-hmm. Basically, where she had sea anemones where the flow forces depended on how much the thing deflected in the flow. The solids and fluids were inextricably mixed. Mm-hmm. And we realized, hey, we got to teach this together. So it's all Mimi's fault. Mm-hmm. But that would have been the late 1970s, and we taught comparative biomechanics together until Steve retired in the 90s, and then I took on the whole course. Because I'd heard him enough so I could do the solids, or at least come in on the chorus. And then a few years later, I ended up having to write this textbook. So I learned a little more about the subject.
Right.
But we didn't quite share graduate students. Occasionally we did. He was more often the official sponsor of grad students, but it was part of it. There was a loosely organized research group. And I say loosely organized, and I mean this in the best sense of the word. I mean, people did all kinds of different things. Wainwright had a very peculiar talent that I've never seen to the same extent in any other person. He could somehow reach into a person's head in a tutorial with a first-year graduate student and figure out just what really that person could do best and kind of edge that person over onto a project that made sense for that particular person. So an astonishing talent for sensing, feeling out the way a person thought and how to apply that productively to a biological investigation. So more different people got launched. And then he was very, very nearly hands-off. But he launched more people onto productive lines of research than you would, anybody could imagine.
That's great.
I don't know how he did it. I watched it for 25 years. I was on the thesis exam after thesis exam, but we were all part of the same group. And so we interacted an enormous amount. And of course, we still see each other frequently. We're both in retirement communities now.
Well, anything else that we should mention before we wrap it up, or?
Well, one more, if you want to record one more, I don't know whether you want to.
Sure, yeah.
At once, it's my nearest I can say to a pearl of wisdom. For a couple of years, I was undergraduate director in zoology. And during the summer, parents would come around with kids who were interested in our field to be undergraduates, and usually between junior and senior year. And a parent would come around with kids, sometimes two parents, and they had the kid's life all figured out. Kid was going to be a great doctor, go to medical school, or was going to go to a marine lab and become a great marine biologist. Those were the two most common. And I got tired of this, listening to this kind of thing. Kid never gets a word in edgewise anyway. So I started to ask the father of the family. I didn't ask Mama because there are other kinds of sensitivities, but I'd ask Papa, what do you do for a living, sir? And they were always interested that you take an interest in them, so Papa would tell me what he does. And I'd ask him, how'd you get into that? And he'd say, well, actually, in my case, it was a bit of an accident. Well, after 5 accidents in a row, I start wondering about the rationality of career choice. Everybody thinks that everyone else made a rational choice. Well, and we have all these guidance departments and so forth. Well, they're all built around the idea that choice is rational, because otherwise you can't organize an advisory system. But I'm no longer, for a long time, I've had the conviction that it's mostly irrational. You choose where you're going the same way as you choose a spouse, in the height of irrationality, in the height of passion. Otherwise, you're not going to do it right. Maybe that's where I want to stop.
That's awesome. Yeah, thanks. Well, thanks so much for talking to me. I had a great time.
You're welcome.
Thank you.